Well, here we are in my shop studio in Clinton, Pennsylvania. I'm Bob Rupert, and this is Iron Hill Forge. And today we're going to talk a little bit about the World Trade Center. Gary Marion Suson of Ground Zero has sent to Eric Hoffman of Henny Jewelries this piece of material. And it's a part of the World Trade Center, which was cut out of one of the beams from its collapse. And it weighs approximately 90 kg, 1.98 pounds. And it's been forged into this billet shape. You can see it's quite uniform at this point. Earlier pictures were of it just being a torched piece, which has been refined to this point. And the end result is going to be numbers and letters for these silver rings, commemorative rings, to be given to the firemen in New York City and the fire departments. So what I've been asked to do is the initial forging of this element, this piece of Trade Center material, is what we're going to do this morning. We're going to refine this down to a plate. The plate that they're requiring is 1 millimeter thick. And then that plate will go to a die striker, and the numbers and letters will be struck out of that plate. So as you can see, this is almost 5/8 of an inch thick by about 2 and about 7 inches long. So they want something 1 millimeter thick, which is about 40 thousandths. And what I've done is we're going to heat this in the gas forge this morning to red hot. And then we're going to use this piece of equipment here, which I've pegged up on the new dies. I've pegged up a space which will give us about 90 thousandths, which I know is a lot more than 40. It's almost double, but they're going to have to machine this plate that I'm going to give them so that it's perfectly smooth, and the die striker has an element that is exactly 1 millimeter thick. He's requiring that 1 millimeter so that he can strike out these numbers and letters. So what we're going to do is I've had my dies resurfaced, and I've made up what they call a peg up, which will prevent these two dies from coming together without a space. So this 90 thousandths piece that's on top of here, I can take off the peg up. This is called a peg up. And that is just a piece I've made up. It's a tool that is 90 thousandths thick. And once that's placed on top of the die and clamped, the two dies cannot come together. They'll be separated by that 90 thousandths, which is the thickness of the plate that we're going to give Henny Jewelry to be taken to the die striker. So this is a pneumatic hammer. It's 110 pound. It beats at 120 or 220 beats a minute, and that will allow us to reduce this down quite quickly. The second thing we're going to use is a gas forge, and I'm going to light that up now so that we can get that warmed up. It's going to become a little more noisy, and now that we have the gas forge lit, it'll start to heat, and we're going to use a pair of tongs to place the element into the fire. And we're going to heat that up in a reducing atmosphere so that we can forge it. This process is quite old. It's hot metal work. It's fairly dangerous, and you have to be required to wear like leather aprons and gloves and whatnot, and for protection. And then what we'll do is, once this is heated to the proper temperature, we'll bring it out of the forge. We'll turn the hammer on, which will be a little more noisy, and then we'll start to forge it down into a plate form. In doing so, we reduce that element without a loss of material, or very little loss. And we're going to try to keep it as clean as possible, so we're going to be wire brushing it every time we pull it out before we start to forge it. And then you'll start to see some of the scale come off, but we want as smooth a piece as we can possibly give them, so that when they start to machine it, they'll come up with a very nice piece of material. You can see it's getting much thinner. You can see now the billet is a lot longer, it's a lot thinner. It's thin here. Let's see exactly how thick it actually is. At this point, we're about 1/4 of an inch, between 5/16 and 1/4 here, and we're about 7/16 up here. So what I'm going to do is reduce this down to the same thickness, and then it's becoming a lot longer. You can see how much longer it is, and we try to make sure that we have uniform lines this way. So I'll need to push this down, and then I'm trying to keep the scale off it also. And the longer we have it out in the atmosphere, the more scale that it creates. So we want to try to make sure we're working in a reduced atmosphere. And that's what I've done here. I'm trying to burn up all the oxygen that I can to make sure we have a reduced atmosphere. That creates less scale. It'll be much more refined and less machining at the end. This scraper, some of the scale becomes quite tenacious. It won't come off, so I use a scraper sometimes to reduce that scale, so we don't hammer it into the element. If we hammer it in, there'll be a divot, and that may not be able to be machined out, which that piece will be lost. So we have to be very careful on how we machine, or how we forge the outside, and try to reducing any dimples in it. Okay, as we go, this forge is only this long, so we're going to wind up with a piece quite long. So I'm going to have to work from end to end in reducing that piece, because it's going to lengthen. It's also going to get thinner. So we have to be kind of mindful of the piece when we get done. You know, what we're going to do, how we're going to heat it. So that's not a bad thing, because once I get one end done, I'll just swap it over and do the other end. As the piece is reduced in thickness, it also cools a lot quicker. So you don't have as much forging time as it gets thinner. It's also a little more delicate. You notice when I forge from the side, that pops the scale off, which helps to clean it. Well, we're about at 3/16 of an inch now. We're about here, and we're going from here to here and then reducing it from there on down. You can see that the piece is starting to hang out of the forge now, becoming quite a bit longer. The sides are fairly uniform. We want to keep a nice straight side on it. This is going to go into a die striker machine, which they'll be able to snap the numbers and letters out of. They can take a sheet up to 4 feet wide in this machine. Now we're down to almost the final forging. You can see 1/8 is real loose. Fairly clean. You can see how much wider it is, how much longer. We got about half of it done. We're at 20 by 2 1/4. You can see the difference in the thickness. We're down to that 90 thousandths down here. still thick up in here, so we're getting there. There's the first half of it. Forged down the thickness, width, length. This section here is still unforged. You can see it's quite thick. And we'll be turning that over, forging that section down. The length is over 2 feet in length, and it's approximately 2.25 inches wide, and quite thin. We need to straighten this into a plate a little bit better. That will be the final forging. Pretty uniform now, a little big on that end. Try and push that together a bit. Here's our finished plate from the billet, and you can see it's a lot thinner. It's about 2.25 inches wide. It's approximately 2 feet. 2 feet 7 inches long. And we'll get our calipers and gauge the thickness along its entirety just to see how even we are. There's about 80 thousandths there. About 95. A little bit more there. Well, about 100. a little bit thicker down at this end. We're a little thick at this end, and we're just real close up here to being correct. What we might do is peg this a little more and forge this portion down. But there you have the billet we started with. You saw the picture of that, and you can see what we finished up with. And then this will have to be machined to remove all the imperfections on the surface. And then I'll go to a die striker, which will snap out the numbers and letters from this piece, which is, I believe someone told me, from the North Tower of the Trade Center. Process took us about 2 hours, 2.5 hours, not including the original forging of the billet, which was about an hour there. So there you have it, commemorative ring plate for the World Trade Center Museum in New York.